Uh-huh. Okay, so yesterday we talked about natural logs, and what was ln? Ln was the same thing as what? Right. So we can ln and log base of e are the same, right? They're equivalent. So wherever we saw an ln when we were taking exponential form or logarithmic form, we could do that replacement, right? So let's look at these. Let's look at these three here. What form is this one in? Exponential, right? This is an exponential form. And every exponential, we can do what with it? Turn it into log form, right? So how would we rewrite this one? What is our base? Base is e, right? So it's going to be a log base e. Then what? 3 is equal to x plus 1. So can we rewrite log base e now? Right. So we can replace log base e with ln. So ln of 3 equals x plus 1. Now what is ln of 3? Right, it's going to be some decimal. So we're going to take that decimal value and do what with it to get x? Subtract 1. So we'll subtract 1 from both sides, and we'll get x. Okay. I'm going to leave that. So what's our final answer then? So x equals 0.098. So now we want to do the ln of 2x is equal to 1, right? So what form are we in? We got natural logs here. We got log form. So how can we take this natural log into exponential form? So we'll put this natural log, right, this ln with a log of a base what? Log base e of 2x is equal to 1. We don't change anything. We're just changing the ln to log base e, right? So now we can take this exponential form. How are we going to do that? So it's e to what power, Alessandra? E to the first power equals 2x, right? So e to the first power we said was just a number, right? E is a number. What value was e about approximately? 2.71. Yeah, and then it keeps going with some decimals. So e to the first power, we can get that out of our calculator, and then to solve for x, what do we have to do? Divide both sides by 2. So what's our final answer going to be? 1.35. I'm going to trust you. On the calculations. All right, so let's take a look at this last one. What form is this one in? Exponential. So we can take this into what other form? Logarithmic. You can always go exponential to log or log to exponential. We can always do that. That's always going to help things become simpler so we can solve. Okay? So we can take this to a log of a base what? Log base. What's our base? The base is e, right? And it's log base e of 0. And that's equal to 2x. And we can rewrite log base e, right? To what? ln of 0. Okay. Do we have, can someone punch in ln of 0 and let me know what they get? Undefined. Okay. So why do you think we're getting that error? It's impossible, but why? Okay, so hold on. When we talked previously, remember when we graphed like log? We graphed log x. Remember when we graphed that a couple sections ago? We had a domain that was restricted, right? So remember where our domain was restricted to? So x had to be greater than 0, right? So we couldn't have negative numbers, and we couldn't have 0. So when we're taking natural logs or logs, we said that if we ever saw a negative, we had to throw out that. That was a no solution problem, right? Same thing if we have a 0, okay? So this one, we can just stop right here. We've got, this is going to give us an error, and that's no solution, okay? X has got to be positive. The number you plug in to a log or a natural log has to be positive. Okay? So this is kind of quickly what we did yesterday. So now we're going to talk about the new stuff. So previously we talked with logs, we had these properties, right? We had three properties for logarithms. We had a product property, a quotient property, and a power property, right? Product property allowed us to do what? Break it up how? If we had something being multiplied, we could break that up with what operation? Addition, okay? And then if we had something that was being divided, we could break that up using subtraction. And then if we had a power, so say we had log of x squared, what could we do with our power? So if we had like log of x squared, what could we do? What did the power property say that we could do with that? So we don't have any multiplication, we don't have any division, we just have this thing that's being squared. What could we do with that? I'll give you a hint. What could we do with this 2? Put it where? In the front, right? So power property said you could stick that out front and rewrite it that way. So natural log is the same thing as log base e, right? So these same properties are going to hold for natural logs. So you're going to still have the product property, you're still going to have your quotient property, and you're still going to have the power property. So let's go through those together now, just talking in terms of natural logs, okay? So we got our product property. It says that we have the natural log of two numbers, x and y. They're being multiplied together. We can just take the ln of x and then add to it the ln of y. All right? And then if we can go the other way too. If we have ln of x plus ln of y, we can rewrite that into one natural log with x times y. Okay, so we can go both ways of these. So let's first look at, if we want to expand this one, we want to expand the ln of 3x. How can we do that? What's it going to be? We want to break that up into more than one log. Or natural log, excuse me. How would we break this up using this property? So we're going to have the natural log of something, right? And since we're multiplying, we break that up with what operation? Addition, right? So we know we're going to have a natural log of something, and we'll add another natural log of something. So what goes in our parentheses here? Say that louder. 3 and x. We just took what's being multiplied there, the 3 times the x, and we broke them apart. Now, if we wanted to really simplify this further, what could we do with the ln of 3? Well, what is ln of 3? What is it? Well, it's a natural log, but what does it give out? Like, if we were to punch this into a calculator, what would we get? We'd get some decimal, right? So this natural log of 3 is a number. So if we wanted to simplify this further, we could write that numeric value out, and then that would be about as far as you go. So you can't do anything with that variable, right? But this is okay for right now. So now let's say we wanted to tackle this one. ln of 4 times 3. What would we do? We want to break this up into more than one log, or natural log. ln of 4. That's right. That's all we got to do. Okay? And we can leave that as it is. So now, if I give you now something that's broken up with addition, so now we have multiple logs here, or natural logs. We have ln of x plus ln of z plus ln of 2z. How could we bring these all together into one natural log? So we have this addition, right? And addition means what? Multiplication. So we're going to take everything we have there, natural log, all the pieces. Since we're adding all the way in between, we're just gonna multiply them, right? So we're gonna have x times z times 2z. So now, since we have that multiplication going on, can we rewrite that in a better mathematical way? What's a better answer here? So we got we have 2z and we have a z, right? Those are common. So we can multiply those together and we'll get a what out? 2z squared, right? Because z times z is z squared. So we're going to rewrite this with the largest power first. So 2z squared times x. Okay? That's all we can do there. Can't take it any further. Questions, concerns? The z, I'm going to draw a line through it so you know it's not a 2. Okay? So that's the product property. So now we have this quotient property now. If we have the natural log of two numbers, x and y, that are being divided, we can break that up into the natural log of x minus the natural log of y. These should be ringing bells that we've seen these properties before, right? Okay, so we can break these up with what operation? Division is subtraction. So ln, if we're doing this first one, the 3 over 7, what's it gonna be? ln of what? 3 minus ln of 7. Okay. That's all we got to do with that one. Done deal. Okay. So now the next one. We got division, right? So what should we do with that division? Subtract, right? So we're just going to take the natural log of the top, the numerator, and subtract off the natural log of the denominator. So now, is there anything else we can do with this one? Okay, you say no, Luis. I'm going to ask you why. So these are being subtracted, right? So we have ln of x minus the ln of 2y. Can we do anything with the ln x? No, there's nothing further we can do. It's a variable. There's nothing else we can do. What about this ln of 2y? Okay, we can separate. We can break that ln of 2y up into what then? So it's 2 and y are being what together? Multiplied. So multiplication is addition, right? So we can break up this whole thing here into a separate addition problem. Now we have to be careful though. We're subtracting this whole thing off, right? When we divided, we broke them up with subtraction. So when we rewrite this, we got to make sure that we include that we're subtracting this whole thing off. Okay? And that's going to be as simple as we could go. Any questions on that? Okay, so now we're going to go the other way. If I give you a bunch of natural logs, I want to bring them down together into one. So what operations we got going on over here? We got addition, we got subtraction. So those are going to be, like you said, multiplication and division. So let's get rid of this addition first. Let's tackle this addition. So if we do that, we're going to get what? ln of 4xy. And then we're going to subtract the ln of 2xz. So now we have this subtraction, right? What do we do with the subtraction? Subtraction means division. When we're combining we're going to take the 4xy and divide the 2xz. So now I'm going to ask you, can we take this and simplify it down at all? Okay, you're saying yes. Why are we saying yes? What can we do with this? Right, so we have a 4 and a 2 in common, right? So we can do some reducing there, and then we can cancel our x's. There's an x on top and a bottom. So we would get what out? 2y over 3. So there's 4 here and the 2, the x here, and the x. Okay? Questions? Concerns? We're doing okay? Great. All right, last property. So if we had the power property of logs, right? Now we're going to talk about the same thing with natural logs. So it's saying here, if we have the natural log of some number x raised to a power m, all we can do is take that power and stick it out front. Okay? So we can just move the powers around. So now let's expand these and condense these using these rules. We're putting them all together. All three rules here are going to be in play. So what's going on if this one? We have this ln of 2y x squared. There's two things going on here. What two things are going on? Okay. We got multiplication going on, right? We got the 2 times y times x squared. And then what else is going on? We're multiplying. We got that. And then there's one more thing that's happening. What else is different? We got this exponent here, right? So we got to work with the multiplication, and we got to work with that exponent. So let's break up this multiplication first. How are we going to break up the multiplication? With what operation? Addition, right? So it's going to be ln of 2 plus ln of y plus ln of x squared, right? We just broke that up. So now, we can't do anything with this ln2. That's just a number. Can't do anything with the ln of y. What about the ln of x squared? What can we do? We can move that exponent out front. And that's going to give us our final answer. So ln of 2 plus ln of y plus ln of, excuse me, I'm going to give the 2 there. 2 ln of x. Okay? Now let's do this next one. We got the ln of the square root of x divided by 2y. Is there a way that we can rewrite this one in a different format? Okay, we're going to divide, right? So we can subtract. So let's do that. We're going to have what? ln of what? Now, is it just x? What about that? What else is up there? Square root of x, right? And then we're going to subtract off what? ln of 2y. Okay, so what can we do? Can we do anything with the square root of x? Okay, you say no. Well, we don't want to change this number, but is there a way that we could rewrite it? Think back to last chapter, first quarter. What could we do? We talked about a lot of roots and radicals. What could we rewrite square root of x as? Okay, so we can rewrite it with an exponent, right? What type of exponent? It's a fractional exponent, right? So when we have square roots, radicals, cube roots, fourth roots, fifth roots, we can rewrite those with fractional exponents here, right? So if we have the square root of x, like Luis was saying, we can rewrite that as x to the 1/2 power for the square root. So these mean the same thing, x to the 1/2. Right? What if we had, say, the cube root? What would be the power of x be then if it was a cube root? 1/3, okay? And so on if we had fourth root, 1/4, that type of thing. So we've taken this a step further. What about the right side? Minus that ln of 2y, what can we do with that? It's what's going on here? What operation with the 2 and the y? They're being what? They're being multiplied, right? So we can break up that multiplication with what operation? Addition. So we're going to subtract off these two, broken up and added. Okay? So now we have that power there. What's the last thing we need to do with that power? Move it to the front. Awesome. So our final answer is 1/2 ln of x minus ln 2 plus ln of y. I know that these are kind of complex and a little bit more involved than maybe what we're used to, but I think that the challenge is nice, and I think you guys are capable of doing it. Okay? So we're not going to worry about this one right here. Don't worry about that. Let's do this 1/3 ln of 8 minus 1/2 ln of 4. We'll do that one, and then don't worry about that other one. Okay? So what's going on here? We want to get this down to one single natural log. What's the two things that are happening? Someone tell me. What two things? There's subtraction, right? And then there's numbers out front. What are the numbers out front? They're powers, right? They're our exponents. So we can rewrite these with their exponents. So it's going to be ln of what? 8 to the 1/3. And then we're going to subtract off the ln of what? Say that a little louder. 4 to the 1/2. So we just brought those powers inside of our natural logs, right? So what is 8 to the 1/3? Is there a way we can rewrite that? There is, right? What did we say fractional exponents were? Right, so we can take these fractional exponents were roots. So this 1/3 is going to be what type of root? Cube root. And the 1/2 is going to be what type of root? So we can rewrite those with roots. So now with that subtraction there, what can we do with it? We can divide, right? So we're going to have the ln of the cube root of 8 divided by the square root of 4. Can we rewrite this in a more simplified fashion? So what is the cube root of 8? So we'd have the ln of what? 2 over square root of 4? 2. So 2 over 2 is what? ln of 1. Do we know what the ln of 1 is? That's a nice one. It's not 1. ln of 1 is 0. So we can rewrite this with a log of a base e x, right? Right? Follow me? We can rewrite ln. How do we rewrite ln? So if we say that this ln of 1 is equal to x, so we'd have log base e of x is equal to 1. Wait, guys, we gotta equals x. So e to the what? E to the what now? E to the x is equal to 1. What's x? It's 0. Anything to the 0 power is 1, right? Okay. We're just evaluating this ln of x, Jalen. I know it was a long problem. Okay. So let's go to the next page here. So at the top we want to write these as a single natural log. Okay, for 1 through 4. And number 5, we want to break those up. And I know that these might be a little bit more complex than what we're used to, but I think that if we use the rules and we go step by step, that we're going to be okay. All right? So give these a shot for homework, and we'll take care of it, okay? So I want to now, so those top 8 are for you. So now let's look at this note here, all right? So if we remember the other day when we had logs on the same side, right? Say we had like log of x plus 1 equals log of x minus 1, right? If we had the same base logs on both sides of the equal sign, what could we do with it? So if we had something like this, if we had the log of x plus 1 equals the log of 2, what could we do with this? We could set what equal to each other? So if we said that if we had logs of the same base, we could take what's in the parentheses and do what with it? This is like 2 days ago, early in the week. We could set what's in the parentheses equal to each other and solve. Remember that? So all we had to do for this one, like what does x have to be for this to be true? What does x have to be for this to be true? X has to be 1, right? So then 2 would equal 2. So we can solve that just by taking what's in the parentheses, setting them equal to each other, right? Remember this? We did this on, I think, Monday or Tuesday. So this same idea is going to hold now for natural logs, okay? So if we have a natural log on both sides, we can just set what's in the parentheses equal to each other and solve, okay? So let's look at this together, okay? If we have the natural log of 2x plus 1 equals the natural log of x minus 1, okay? We have natural logs on both sides. So what we can do is just take whatever's in the parentheses and set them equal to each other and solve, right? So that's all we got to do. We just set 2x plus 1 equals to x minus 1. It's right here. And then now that's just solving, doing some algebra, okay? So let's go through this the right side one together. If we have a natural log on the right side, right? We have one of those. So that right side's good. But what do we want to do on the left side then? What can we do with that 2 natural logs that are being added? We can multiply them down, right? We can get them down to one natural log. So how would we do that? So how do we multiply this? So it's going to be ln of this one right here multiplied by that, right? X plus 1, x minus 1. So now we have a natural log on one side and a natural log on the other. So for this to be true, that expression to be true, what needs to be set equal to each other? What needs to be set equal to each other? The parentheses, exactly. So we take what's in the parenthesis here. And we just set them equal to each other. So we're going to have x plus 1 times x minus 1, right? That's what's in here. And we're going to set it equal to what's in there. Okay? Everyone's okay? Everyone's with me? Okay. So now we just got to do what? We just got to solve this. We just got to solve this together, right? So what can we do with the left side? What can we do with that? We can FOIL it, exactly. So how would we FOIL this? What would it be? X squared. We just said minus 1. Right, so we'd get a positive x and a negative x, so the x's are going to cancel out. And then a 1 times a negative 1, negative 1. So I'm going to, so minus 1, that's equal to 3, right? So now what? What's the next step? Add 1, so we get x squared is equal to. So what are our two answers? X is going to be equal to plus or minus 4, right? We can take the square root of both sides. Take the square root of both sides. And the square root of 4 is going to give you that plus or minus 2. Okay, so we got two answers out here, right? We got to make sure they both work. So how can we do that? We can check it, right? We can plug those back in. So we can take 2 and put it in where we see an x in our original. So if we do that, we get, so what's the ln of 2 plus 1? That's an ln of 3 for the first one, right? We put in 2 for x. And then ln of 2 minus 1, that's just ln of 1, right? So we can put those in our calculator and make sure we get ln of 3, right? So with that, we can check that one. That one's good. Now what if we put in the negative 2? What happens? If we put in negative 2 for x, what do we get for that first natural log? We get negative 1, right? Can we take natural logs of negative numbers? No, right? So is negative 2 a solution for our problem? No. It's going to give us these non-real number solutions for our natural logs. So we can throw out the negative 2 answer, and x is going to be what? 2. Okay? So that's all we needed to talk about today. We got 12 problems there for homework. Give them a shot, and we will pick up on this again on Monday, okay?